to work out empirical formula as opposed to molecular formula that was asked earlier is to do with the simplest ratio of atoms. Okay, that's why we put down atoms and not molecule. Atoms, because definition says it's the simplest ratio of atoms present in the compound. Yeah? So I have the mass per 100 gram. That is mean I can convert the percentage into gram. That's out of 100 gram, how many of each is actually each atom. Yeah. So the mole is going to be the mass over the mR. The mass over the mR. The mR there is 16 because it's the oxygen atom, not oxygen molecule. Same with the hydrogen, not 2, because the empirical formula is defined as the simplest ratio of atoms. That is the most common mistake. People don't get definition and they're like, oh, but it's, all the time it's always covalent molecule. So you got to keep an eye out for definition and think about the value and the meaning of definition instead of just, learning it for the sake of learning it. Okay, it doesn't work like that. It works better if you know what you're talking about. Yeah. So divide by the simplest ratio. Well, essentially I want the simplest ratio, so I need to divide by the smallest number. So the smallest number is 1.22. That will give me 2. 3.7 over 1.22. That give me 3. 2.44. I just run it up to make my life easy. That's just 2. 1.22 over 1.22 is just 1. Therefore, the empirical formula is just C2H3O2 Na. Okay, where the Na is just 1. Next bit, empirical formula, which is the simplest ratio of atoms, okay, in the formula unit. So they say it contains carbon and hydrogen, but if you read the question, it is a compound containing carbon, hydrogen, and oxygen. But guess what? They only give you this and this, which means most people would just think like, oh, it's just carbon and hydrogen. But if you just contain carbon and hydrogen, that is called hydrocarbons. That wouldn't be called an acid. And that thing wouldn't contain oxygen. But U is not a hydrocarbon. It contains carbon, hydrogen, and oxygen. If you just work out based on this value, you are just having C and H. That would be hydrocarbon. That means you don't know what is hydrocarbon. That means you don't know the definition of it, and that means you really should look back at your definition. There's actually another thing, oxygen. This is the total mass. They tell you the mass of carbon, they tell you the mass of hydrogen, and you know mass of carbon plus mass of hydrogen plus the mass of oxygen equal to this. Therefore, we can talk about the mass per 100 gram. This is 1.68 carbon, this is 0.14 gram hydrogen. The oxygen is going to be the total mass minus the carbon plus the hydrogen. I use a bracket very carefully, okay? Otherwise, you might make a mistake there, okay? 1.68 plus 14, 4.48. Alright, so that's the mass. Now you want the mole. The mole is going to be divided by the atomic mass of the element, of the atom. It cannot be of the molecule because the definition empirical formula is the simplest ratio of atom. So you want the simplest mole ratio of the atoms. That's why you cannot divide by 2 because 2 is for the molecule, not the atom. The atom is only 1. The atom is only 16, not 32. Alright? Do that on your calculator. You're going to get 0.14. This is 0.14. That's 0.28. You want the simplest mole ratio. So the smallest number is 0.14. So you do 0.14 over 0.14, that's 1. 0.14 over 0.14, that's 1. 0.28 over 0.14, that's 2. The simplest ratio is going to be C1H1O2. When it's 1, I do not show the 1, okay? It's implied. This should be a trademark thing which you shouldn't lose unless you just have CH or whatever, okay? That means you have totally missed reading the question. That's why it's important to read the question and interpret the question, yeah? Next bit, empirical formula. So work out copper, cesium, and chlorine by mass. So you will see that the total percentage add up to 100%. So this is mass per 100 gram. So you can convert it into 21.09 gram, 43.82 gram, 35.09 gram. Then work out the mole. So the mole is going to be the mass divided by the molecular mass, the atomic mass, sorry. So copper in the periodic table is going to be 64. Well, I think it's 64 in your periodic table. So the next one is cesium, it's 133. This is 35.09 divided by 35.5. So work that out on your calculator. So it's going to give you 0.33. I'm just rounding it up because I know I need to do something else in the next step, which I'm going to show you. 0.33. This is 0.99. You need to divide by simplest ratio. So out of the three value, the simplest ratio is 0.33. So you divide by 0.33. Same thing goes for there. 0.99 divided by 0.33. It's going to give you 1, 1, and 3. So your empirical formula is 1 copper, 1 cesium, 3 chlorine. Okay, that's it. Okay, empirical formula. So this is aluminium chloride. Anhydrous means no water. And then we just know that the mass per 100 gram. So that's just basically the mass in percentage. There's 20.2. Therefore, since it contains aluminium and chlorine, only the remaining mass will be the mass of chlorine. So there's 100%, which is 100. Well, out of 100 gram, there's going to be 79.8 gram of chlorine. So the mole is going to be 20.2 divided by, have a look on your periodic table. Aluminium is 27. That is 79.8 divided by 75.5. 35.5. 35.5. So that's going to give you, if you put in your calculator, 0.75. That is going to give you 2.25. You divide by simplest ratio. I mean, this is the kind of working you need to establish empirical formula. You got to label your working very clearly, very neat. You don't need a proper table with lines, but as long as it's clear the direction that you're doing in, there's no point of drawing a table unless you really want to, I guess. But it's perfectly clear as you lay out your working, you lay out the labels, examiner can read it, and you should be alright as long as you show all the working. And you can get the correct answer as well. But it just depends on how much time you have, because different people will have different amount of leftover time, and you need some time to check your answer as well. So therefore, your empirical formula is aluminium trichloride AlCO3, as they ask you to show. Okay. The next bit is saying that so they're saying that they give you the mass, they give you the mole, so you should know mole equal to mass of mR. So they want you to find the mR. So the mass, which is 2.34. So I've just brought, or maybe I should show one more step just in case you need it. mR is therefore mass over mole. mR is 2.34 gram divided by 0.00876. The mR based on the calculation is going to be 267.1. Based on the formula you had just now, that is empirical. You're gonna get something like that will give you 267.1. So work out the mR there. So there's 27 plus 35.5 times 3. You don't know the multiple here. You don't know it. So multiply by n is equal to 267.1. Multiply that throughout. You're going to get 133.5 times by n. 267.1 you bring the 133.5 to the other side, it's going to be divide. So 267.1 divided by 133.5. You're going to get around 2.00 something. There's 2. Therefore, your molecular formula is going to be AlCO3 twice, which means Al2CO6. Okay? No, okay there. CO6, so there's 267.1. You can run it up to 267 maybe, because the data given is 3 sig fig, 3 sig fig. So I will just leave it as 267 because it's appropriate data based on what is given as 3 sig fig, 3 sig fig. Next bit is showing empirical formula. So you have an oxide of phosphorus, so that means only oxygen and phosphorus. If phosphorus is 43.7, if this is mass per 100 gram, so that means you can convert the percentage to 43.7 gram, okay, mass per 100 gram. So there's 100 minus 43.7. This is a percentage. There are only two things. If this is the percentage of phosphorus, what is the percentage of oxygen? So that's going to give you 56.3. Then you need the mole. So go to your periodic table. That's going to be divided by 31. That's going to be divided by 16. That's going to give you that's going to give you 1.4. That's going to give you 3.5. You need to divide by the simplest ratio. So the simplest ratio here is 1.4. That's going to be 1. 3.5 divided by 1.4 is 2.5. So when you see a case like this, you really cannot put down 2.5 like that, and you know this is what you want to get. Multiply by 2 to get a whole number. 1 times 2 is 2. 2.5 times 2 is 5. Therefore, you know the empirical formula is P2O5 as required, yeah? So the sample contains that much mole of the oxide. This is working out molecular mass, so very standard kind of question, yeah? So P2O5 multiplied by something would give you... hang on. So they give you the mole, they give you the mass. So the mole is the mass over the MR. The molecular mass is going to be M over N. So you just move this up and you move the N down there. So 2.56 over 0.0901. You're going to get 2 at 4. 2 at 4.1. So this MR is 31 times 2 plus 16 times 5. There's 142 there. So N is going to be, okay, maybe I shouldn't use N because I already have mole as N. A maybe. So A is going to be 2 at 4.1 over 142. That's 2. That means the molecular formula is going to be P4O10. Again, standard year 9 or year 10 mole calculation, molecular mass calculation from empirical formula, yeah? So that is 2 at 4. I should probably round this up to 3 sig fig based on the data given being 3 sig fig there and also there. Okay. Pretty straightforward, but they want the structure and bonding in silicon dioxide. Case study, yeah? So this is a component of sand. So there's SiO2. There is giant molecular structure. But the bonding is covalent bonding between all the Si and the oxygen. That's it on the previous question.